Alright, in this lesson we're going to do parent graphs of the rest of the trig functions. So we're going to start with cosecant x with just our x table and our y table. The period of this, remember this is the reciprocal to the sine function, so we'll see a lot of similar characteristics and such, that the period is 2 pi, although it doesn't have an amplitude at all, and we'll see this more as we graph it. Okay, and we'll discuss more about the domain and range later. So let's just go around our unit circle. Okay, so we recall that this cosecant is going to be 1 over sine of x. Okay, so let's go to when x is 0. What is 1 over the sine of x? The sine of x is 0, so that would be 1 over 0, right? Which is going to be undefined. Alright, let's do pi fourths. What's pi fourths? We come over here to pi fourths. 1 over the y value, which is going to be square root of 2 over 2. Now, you can put that in your calculator and do the calculation to that. And remember, we used decimal approximation, so we're going to say that's going to be approximately 1.4. So test that in your calculator or simplify it algebraically first and then plug it in, and you can see that. Let's continue to pi over 2. Pi over 2 is going to be 1 over 1, which is just 1. Let's check at 3 pi over 4. We're over here, so cosecant of that is going to be 1 over the y value, so we would have 1.4 again. Pi is 1 over 0, which is undefined, and pause it. We're going to finish the rest of these out going around the unit circle. Remember, all these calculations are being determined by 1 over the sine of x. Okay, so check those answers. The first thing I'm going to do is go to the undefined values and put a dashed line. So at 0, it's undefined here. Also at pi. And looks like at 2 pi. Now, in black, if I had my sketch of just my sine function, let me see if I can do a rough sketch of that. Right, that's my sine function. So understanding that this is a reciprocal, let's see how that plays out. So first of all, let's go to pi fourths and about 1.4. Pi fourths here at 1.4, we're going to be a little bit off the graph a bit, but now let's do pi halves is at 1. So I go over to pi halves up to 1. 3 pi fourths over here is approximately 1.4. So roughly we can see when we get to pi it's undefined. 5 pi fourths, I jump down here to negative 1.4, which would be here. 3 pi over 2, pi over 2. So you can see that if I was to approximate this, now remember that these are going to keep going. This will never cross this horizontal asymptote right here. This vertical asymptote, excuse me. So this is never going to cross this asymptote, never going to cross this asymptote. And I come down here. Let me see if I can get a little bit further. And same thing. Okay, so precisely the blue figures only, the blue graph is going to be your parent graph of your cosecant x. And like I said, a lot of times the easiest thing to do is to sketch a sine graph and then to sketch your images based on that. Okay, let's do a similar thing with our secant x. Okay, so we have y equals secant x is the next one we're going to look at. We have an xy table set up. Our period's 2 pi. It has no amplitude. And we recall that the secant of x is evaluated by 1 over the cosine of x. So if we have our, let me see if I still have a unit circle, then we can calculate these values. So let's go when x is 0. When x is 0, what is 1 over that value, 1 over the cosine of x? It's just going to give us 1 over 1, right? Which is simplifies to 1. Let's do secant of pi 4. So we go to pi 4s. 1 over the x value is that 1 over the square root of 2 over 2. Like we said, we would simplify that in the calculator and use the decimal approximation for graphing purposes. Alright, what about at pi halves? What's 1 over the x value here? Undefined, good. So we have undefined. Then we go to to 3 pi over 4, and we would get negative 1.4. Okay, at pi, you're going to have 1 over negative 1, which simplifies to negative 1. Okay, pause it and work your way around the rest of the unit. Okay, and next we want to actually plot these. So go ahead and do that. Okay, so when we sketch that, you can see the solid curves are going to be the ones that we plotted. I just did the dashed ones to extend it so you can see that these are going to just keep on going and extending in either direction for however many points we want to do. And also recognize that this is the cosine. You know, if I did the going down, did the image of the cosine, we can see how these two have the relationship there. So let's look at the next two. Okay, so we completed this chart. We can see that one cycle, these are just going to keep continually repeating, and this isn't the best graph of that. So maybe look at a particular one. This is from the internet. So y equals tanx, and then this one's going to be our cotangent x in just a minute. But you can see the shape's a lot better depicted than my particular graph. But the period is pi. It's going to go through the origin. You can see one of the cycles is here, and it increases to the right. Let's look at a graph of cotangent x next, which is the reciprocal of this one. Okay, and so our cotangent, here's our xy table for that, and a rough sketch over here to the right. The period is pi. A cycle of one of these happens in pi units. The parent graph does not go through the origin, and it decreases to the right, meaning so when I move to the right, you can see that as I follow along the graph, it decreases. Okay, the next thing we're going to do is we're going to actually graph some of these variations of the past functions that we've looked at, cosecant, secant, tangent, and cotangent. So let's look at a couple of these.